Hello, welcome to In 5 Minutes. Today's concept is the base width modulation. Consider an NPN BJT NPN transistor again operated in active mode. Why active mode? What do you mean by active mode? JBE, that is base emitter junction, is forward bias and JBC is reverse bias. When you look over here, the base emitter junction, when you draw diode over here, base is positive, that means JB is forward bias, JBC is reverse bias. That means we are operating the transistor in the active mode. Now if we are voltage, the reverse bias voltage over here between the P and N region, you know the width of the base is less, initial width of the base is less as compared to the NP and NN. Both the N regions, the largest area is for the collector and the smallest is for the base. For representation, for understanding the concept, I have shown a larger area over here, but the obvious length of the base, you can say width of the base, is very less as shown in the diagram. It is just for understanding the concept. I have shown the base as a larger area. Now initially when your reverse bias voltage is less, there is a potential barrier or depletion region generated between P and N, right? So without VC applying any reverse bias, you have the depletion region created between P and N, which has an potential barrier created, or you can say the potential barrier created or the voltage because of the ions in the region which is called as the space charge region or the depletion region. Now as you increase the collector to base voltage, that is you are more reverse biasing the PN junction diode. So what will happen because of this? See here, this was the WI is nothing but the initial width of the depletion region when your VCB was less. Now when you are increasing VCB value, what will happen? The depletion region width will increase and it will penetrate more into the base. When it is penetrating more into the base, the width of the base decreases. This WI is the initial width of the base and WF is the final width of base. When you look at the diagram, you can see the initial width is greater than the final width. So as you increase the reverse bias, the width of the base decreases, right? What will happen if the width of the base decreases? What is the effect of it on IB? As you are decreasing the width of the base, recombination in the base decreases. When the recombination decreases, the current which is generated because of recombination decreases. This is the effect of what? Base width modulation. It is also called as early effect. The concept of early effect. Since the width of the base decreases, your IB current decreases. Now what is the effect on the collector current? Collector current is the movement of electrons from base to collector that generates the collector current. Since the width of the base is less, the recombination of electrons happening in the base is less, so more numbers of electrons will drift from base to collectors. This will increase the collector current. Now what is the effect of increase in VCB on the emitter current? As the number of recombination is less, more number of electrons are drifting towards the collector. The number of electrons over here decreases, so you need to provide more number of electrons. So this more number of electrons is taken from negative terminal of the power supply and hence IE also increases. This is the effect of early. This is the effect of the reverse biasing, increase in the reverse bias voltage, which is also called as base width modulation. Why it is called as base width modulation? As you increase the reverse bias voltage, the width of the base changes, hence it is called as base width modulation concept.